Welcome to TRL. This is a third lecture on vectors. In this lecture, we're going to deal with the ratio theorem. We'll first look at the internal division of the magnitude between 2 points, and we'll lastly look at the external division of the magnitude between 2 points. Let's look at some things to note before we begin this particular lecture. Given three vectors, vector OA, vector OB, and vector EB, if we let vector OA have a position vector A, vector OB a position vector B, then the position vector of AB is B minus A. Why? This is because we know that vector AB is vector AO plus vector OB. That is, for us to move from the point A to the point B, from the point A to the point B, we have to go through the point O to the point B. That is AO plus OB, AO plus OB. Now this means that vector AB equals minus vector OA plus vector OB. That is AO equals minus OA. This is because we know that OA moves in the positive direction, so negating OA will give us AO. So we have that vector AO equals minus vector OA. But for us to move to the point B, we must go through the direction of AO, which is the negation of OA. Now this expression means that vector AB equals minus vector A plus vector B. That is minus vector A plus vector B, because we are negating vector OA, which means we are negating A. So you have minus A plus B. This can be rewritten as vector AB equals B minus A. That is, given a particular vector, that particular vector can be written as the position vector of the terminal point, which is B, and that of the initial point, which is A. So you have B minus A. As examples, we have that the vector DE can be E minus D. That is, DE equals the position vector of OE minus the position vector of OD. MN can be N minus M, XY can be Y minus X, and vector PQ equals vector Q minus vector P. Now, let's divide this particular slide into two sections. That is the internal division and then the external division, and we'll deal with them simultaneously. Let vector OE and OB be two different vectors with the same initial point. That is, let vector OE and vector OB be co-initial vectors. So at the left hand side we have vector OE and vector OB, and the right hand side we have vector OA and vector OB. Now let OC be a different vector with the same initial point. So we have that OC is a different vector with the same initial point. That is, vector OA, OC, and OB are co-initial vectors. Now the location of vector OC is very important in each section. In the internal division section, we have that vector OC is in between vector OA and vector OB, whereas in the external division section, we have vector OC to be after vector OB. So in the internal section, we have OC to be in the middle, and we have OC to be after vector OB in the external division section. Now clearly you can see that C divides the magnitude between the point A and the point B into two parts, and is done internally, whereas in the external division section we realize C divides the point A and the point B into two parts but externally. Now in the internal division section we have that vector OC divides the magnitude of between the point A and the point B into alpha and beta respectively, whereas in the standard division section we have that the vector OC divides the magnitude between the point A and the point B into two sections. We have alpha and we have beta. That is the magnitude between the point A and the point C is alpha, and that between the point B and the point C is beta. Now, in the internal division section, we have that the magnitude of vector AC is divided by vector CB equals alpha is to beta. We can rewrite this particular expression as magnitude of vector AC over magnitude of vector CB equals alpha on beta. This means that beta times magnitude of vector AC equals alpha times magnitude of vector CB. And then we know that AC can be written as the position vector of OC minus the position vector of OA. So we have beta times vector C minus vector A, which equals alpha times vector B minus vector C. So we have beta C minus beta A equals alpha B minus alpha C. Grouping like terms, we have alpha C plus beta C equals beta A plus alpha B. Factorizing the common expression out to this vector C, we have C times alpha plus beta equals beta A plus alpha B. Making sure the subject, we have beta A plus alpha B all on alpha plus beta. That is, for us to look for the position vector of OC, we use this particular expression. That is B times the position vector of OA, which is E, and alpha times the position vector of OB, which is B, all on alpha plus beta. This yields and gives us the position vector of vector OC. And it also tells us the ratio between the magnitude of the points A and B. In this case, now look at the time section. We move from A to C, then C to B. So you have from A to C, then C to B. So in this case, we move from A to B, then B to C. So we have in initial expression that the magnitude of vector AC is to magnitude of vector BC equals alpha is to beta. That is, move from A to C and then B to C. So we have this expression, which means that we have beta times the magnitude of vector AC equals alpha times the magnitude of vector BC. So we have this expanding. We have that group like terms. We have beta C minus alpha C equals beta A minus alpha B, which means that C equals beta minus alpha equals beta A minus alpha B. Which is the subject, we have beta A minus alpha B on beta minus alpha. So if the operation at the numerator and denominator is positive, then we are dealing with the internal division section. But if it's negative, then we are dealing with the external division section. In summary, on this particular slide, we have that C divides the magnitude between the point A and the point B into two equal ratios, that is alpha and beta. Similarly, in the external section, we have alpha and beta, but in this case, move from A to the point C is alpha, then move from the point B to the point C is beta. So in this lecture, we've looked at the division theorem, that is the internal division and external division of the magnitude between 2 points. In our next lecture, we're going to look at what linearly independent vectors are, what linearly dependent vectors are. Then lastly, we'll look at coplanar and non-coplanar vectors.